Okay, guys, we are going to do today's chapter 1, section 6b, and I'm going to split this into 2 parts. We're going to do 8 examples today and finish up the notes tomorrow. We're going to be talking about solving other equations where radicals are involved. So for today's lesson, what we need to do is focus on isolating the square root. That means you get the square root all by itself. We'll square both sides of the equation to get the root to go away. And then we will solve the problem, but we have to make sure, we have to make sure, guys, that we check all of our answers every time. We cannot just assume that they always work. Whoops. So first problem I look at, all right, like we said, we're going to isolate the radical. So I'm going to circle my radical here and I'm going to say, okay, I need this to be all by itself. So since it's negative here, I'm going to move it to the other side. So this will leave me with x equals the square root of 15 minus 2x. Well, now that our radical is by itself, we can undo the radical. So I'm going to square both sides. When you square a square root, it goes away. So you're left here with x squared equals 15 minus 2x. So now I have a quadratic. I have an x squared, and then I have an x and a number. So I'm going to move everything to one side. So let's just move everything to one side and then solve. So x squared, when I bring 15 over and negative 2, this is going to become plus 2x minus 15 equals 0. And let's see if we can factor, which thankfully it does. What are the factors of negative 15 that are going to multiply to give me negative 15? But add to give me a 2. That's going to be plus 5 minus 3. And then when I go to solve, I have x equals negative 5 and x equals 3. Now at this point, guys, this is where we need to go back and check to make sure that both of these solutions satisfy the equation. So go back to the original. And I'm going to plug in negative 5 and see what happens. So my original equation, it would be negative 5 minus the square root of 15 minus 2 times negative 5. Does that equal 0? So negative 5 minus, well, 15 minus, negative 2 and negative 5 is 10. So 15 and 10 is going to give me 25. Equals 0. So negative 5 minus the square root of 25 is 5 equals 0. Negative 5 and negative 5 is negative 10. Does that equal 0? No. So is negative 5 an actual solution? No, it's not. So let's check 3. So I'm going to plug in 3. I have 3 minus the square root of 15 minus 2 times 3. Does that give me 0? 3 minus, well, 15 minus 6 is 9, so 3 minus the square root of 9, 3 minus 3 equals 0. We're good. So our solution here is just x equals 3. That's why it's really important to check to make sure that both solutions work. So let's move on here to number 2. Again, we have the same thing. I don't know why this square root is extended a little bit with our PowerPoint, so we can go ahead and fix that. But again, I have a radical that I need to isolate. So since it's negative, I'm just going to move it over here. This is going to become x equals the square root of 3x plus 18. Now that my radical is by itself, I'm going to get rid of that radical, so I'm going to square both sides. So this becomes x squared equals 3x plus 18. Again, this is a quadratic. I have an x squared and an x. So let's just move everything to one side. So x squared, we'll subtract 3x and subtract the 18. And we get 0. So guys, let's go ahead and factor this. I have x times x, and then what are the factors of 18? That'll give me a negative 18 when I multiply, but a negative 3 when I add, and that'll be negative 6 and positive 3. So when we solve, we get x equals 3 and x equals 6 and x equals negative 3. So now let's check. We have to plug our solutions in and check to see if they're correct. So plug in 6 minus, well, 3 times 6 plus 18. Does that equal 0? So 6 minus 18 plus 18 equals 0. 6 minus the square root of 36. What's 6 minus 6? 0. So we're good. So x equals 6 is a solution. So now I'm going to check negative 3. So I have negative 3 minus the square root of 3 times negative 3 plus 18. Negative 3 minus, this is negative 9 plus 18. So negative 3 minus the square root of 9. Negative 3 minus 3, does it equal 0? No, it does not. So x equals negative 3 is not a valid solution. It's extraneous. All right, let's scoot on down here. Again, the same thing. We want to isolate our radical, and then we will square both sides. So I have nothing I need to do here. I don't have to move anything anywhere. I could just go ahead and square both sides. So when we do this, guys, remember, when you are squaring here, this does not apply like this. You can't just say, oh, 2 goes to the 2x and 2 goes to the negative 1. No, 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 absolutely not. You got to remember that. So when we square a square root over here, we have 4x plus 13. And then over here I have 2x minus 1 times 2x minus 1. Good. And now we're just going to go ahead and FOIL, combine like terms, all that good stuff. So I'm left with 4x plus 13 over here. On the right-hand side, 2x times 2x is 4x squared. 2x times negative 1 is minus 2x. Negative 1 and 2x is minus 2x. And negative 1 and negative 1 is going to give me a plus 1. So let's clean it up a little bit. We still have 4x plus 13 over here. I have 4x squared. When I combine these two, I have minus 4x, and then I have plus 1. So I have x squareds and I have x's. So I need to get everything to one side, and then we can factor. So I'm just going to move to the right. So I'm going to minus 4x and minus 13. Minus 4x minus 13. And we're going to have 4x squared minus 8x minus 12 equals 0. So now as a factoring problem you guys have seen a million times. First thing we're going to look for is a GCF. Is there a number that I can take out of all three of these? Yes, that we're going to factor out of 4. We'll be left with x squared minus 2x minus 3 equals 0. Still have my 4 out in front. Are there factors of negative 3 that'll multiply to give me a negative 3 and add to give me a negative 2? Yes, that'd be x minus 3 and x plus 1. So when we solve this, we have 4 equals 0, x minus 3 equals 0, and x plus 1 equals 0. So this is an untrue statement, so don't have to worry about that. Here I have x equals positive 3, and here I have x equals negative 1. Now what do we need to do, guys? We need to plug back into the original and check. So I'm going to try 3 first. I have the square root of 4 times 3 plus 13 equals 2 times 3 minus 1. So this is 12 plus 13, that's the square root of 25, equals 6 minus 1. So the square root of 25 is 5, equals 6 minus 1 is 5. So yes, x equals 3 is a solution, it's a valid solution. Let's go ahead and check negative 1. Plug back into our original. So I have 4 times negative 1 plus 13. Does that equal 2 times negative 1 minus 1? So 4 times negative 1 is negative 4, plus 13 is going to give me square root of 9, equals negative 2 minus 1. So the square root of 9 is 3, and negative 2 minus 1 is negative 3. Are those two things exactly the same? No, they're not. So is x equals negative 1 a valid solution? No, it's not. That's why it's so very important, guys, to check every solution every time. So now we come up to number 4. Okay, you guys are doing great, moving right along. We're going to isolate our radical. Is my radical by itself? No. So what do I need to do? I'm going to add 1 to both sides. So I'm left with the square root of 6x plus 7 equals x plus 2. So now what do? Get rid of that radical. We're going to square both sides. When you square a square root, I'm left with 6x plus 7. Here, this is x plus 2 times x plus 2. So when we FOIL that out, we get x squared plus 4x plus 4. So we're going to move everything to one side and solve. So I'm going to subtract 6x and subtract 7. Subtract 6x and subtract 7. So I have 0 equals x squared minus 2x minus 3. So now we see, can we factor this? What are the factors of negative 3 that are going to multiply to give me negative 3, but add to give me negative 2? It's going to be negative 3 and positive 1. So I get x equals 3 and x equals negative 1. And again, what do we have to do before we just go, yay, we got it right, we're so smart? We need to go back and check. So let's throw these in and see what happens. So the square root of 6 times 3 plus 7 minus 1 equals 3 plus 1. So 6 times 3 is 18, plus 7 is 25. So the square root of 25 minus 1, does that equal 3 plus 1? 5 minus 1 is 4. 4 equals 4. We're good to go. So x equals 3 is a valid solution. Let's try negative 1. So I have 6 times negative 1 plus 7 minus 1 equals negative 1 plus 1. Well, 6 times negative 1 is 6. Negative 6 plus 7 is going to give me the square root of 1 minus 1 equals negative 1. 1 is, so square root of 1 is 1 minus 1. Does it equal 0? 0 equals 0. So look, this one works as well. So you can't just assume that when you plug back in, oh, one of them works, so the other one won't. You can't just assume that both of them work all the time. You've got to go back and check your work. All right, moving along. Let's look at number 5. All right, number 5 is a little different. It has two radicals, excuse me, on the same side of the equation. So what we need to do is move one to the other side so that we can then square both sides of the equation. You cannot square both sides with the way that it's set up with both of them on the same side. So I'm just going to take this radical and move it over here. It's negative. I'm going to move it, make it positive. So when I do that, I have 2x plus 3 underneath the radical equals, and then I have 1 plus the square root of x plus 1. All right, so I have radicals on either side. We're good to go. I can't isolate them. I can't combine them or anything. So what I'm going to do now is square both sides of my equation. So when I square this square root, this becomes 2x plus 3. Over here, we're going to FOIL. Right? This is the same as 1 plus x plus 1 times 1 plus square root of x plus 1. So 1 times 1 is 1. 1 times the square root, so I have plus square root of x plus 1 plus the square root of x plus 1. And then when I multiply these two things together, the square root cancels. So I'm just left with x plus 1. So let's see what we can combine, and we'll be able to then solve the equation. 2x plus 3 over here. I have a 1 here and a 1 here. That gives me what number? 2. Good. Plus, how many square roots of x plus 1 do I have? I have 2. So those are combined. We're good. And I have this little old x hanging out, so we got to keep that. So now we're going to go back to how we originally had our problem with just one square root in it. We're going to say, oh, I've got to isolate this square root. So what are all the things I have to do? Well, I need to subtract x and subtract 2. So subtract x and subtract a 2. This will leave me with x plus 1 equals, that cancels, that cancels. So you have 2 times the square root of x plus 1. Now we're going to divide both sides by 2. Divide by 2, divide by 2. Perfect. So I'm left with x plus 1 over 2 equals the square root of x plus 1. Now what do I do to get that square root to go away? We're going to do what? That's right, we're going to square both sides. So I'm going to square here and square here. So when I do this, I know this is getting a little yucky. You guys are doing great. Just hang on with me. So I'm left here with x plus 1 on this side. And then remember, this squared goes to the top and to the bottom. So this is x plus 1 times x plus 1 all over 2 squared is 4. So let's just clean this up a little bit. X times x is going to give me x squared. X times 1, and then 1 times x is going to give me 2x, and then 1 times 1 is 1 over 4 equals x plus 1 over 1. Now what do we have here, guys? We have a fraction equal to a fraction. We have a rational. So I can now say, okay, I can cross multiply. I can say 4 times x plus 1 equals x squared plus 2x plus 1 I'm going to go ahead and distribute here. So I have 4x plus 4 equals x squared plus 2x plus 1. And now that I have a quadratic, I'm going to get everything on one side. So minus 4x minus 4 minus 4. We're left with x squared minus 2x minus 3 equals 0. So we're going to go ahead, factor and solve. So x minus 3, x plus 1. I have x equals 3. And x equals negative 1. Now, before I go, whoa, that was a long problem. I'm so glad I'm done. What do I need to do, guys? Have to go back and check. So let's go ahead and plug in 3. So I have the square root of 2 times 3 plus 3 minus the square root of 3 plus 1. Does that equal 1? Well, 2 times 3 is 6, plus 3 is 9, so square root of 9 minus 4 plus 3 is square root of 4 equals 1. Square root of 9 is 3. Minus the square root of 4 is 2 equals 1. Does 1 equal 1? Sure does. So x equals 3 is a valid solution. Let's try negative 1. So the square root of 2 times negative 1 plus 3 minus the square root of negative 1 plus 1 equals 1. So I have negative 2 plus 3 is the square root of 1. Minus the square root of 0, does it equal 1? Well, the square root of 1 is 1, minus 0 equals 1. So x equals negative 1 is a valid solution. All right, good job. Let's move on then to number 6, please. We're going to do number 6. Again, guys, the same way. Notice how we have two radicals that are separated by a minus sign. So we can't just square both sides. We got to get one to one side, one to the other. So I'm just going to take this radical, square root of x minus 3, and move it over here because it's negative. I want to make it positive. So I have the square root of 2x minus 5 over here equals, and then I have 1 plus the square root of x minus 3. So our process now is to square both sides. When you square a square root, it cancels out. So 2x minus 5 equals, now we're going to FOIL. 1 times 1 is 1. 1 times root x minus 3, and then another one is going to give me plus 2, square x minus 3. And then when I multiply those two together, it's just going to give me plus x minus 3. So what can we combine? I have 2x minus 5 equals 1 and negative 3 is going to give me negative 2 plus 2 square root x minus 3 plus x. So again, same thing. We're going to move the x and the number to the other side. So my x's will cancel here, my 2's cancel here, so I'm left with 2 radical x minus 3 over here. And then 2x minus x is leaves me with x. Negative 5 and 2 gives me minus 3. So now we're going to do what? We're going to divide both sides by 2. So we divide both sides by 2, and then to get rid of this radical, we're going to square both sides. So remember, guys, when you square both sides, it goes to the numerator and the denominator. So we're going to have x minus 3 times x minus 3 over 2 squared is 4 equals x minus 3 over 1. So x squared minus 6x plus 9, we FOIL at the top, over 4 equals x minus 3 over 1. Cross multiply. 4 times x minus 3 equals x squared minus 6x plus 9. 4x minus 12 equals x squared minus 6x plus 9. I have a quadratic, so I'm going to move everything to one side. So minus 4x and plus 12. Minus 4x and plus 12. So we're left with x squared minus 10x plus 21 equals 0. So I'm going to go ahead and factor and say, okay, I need factors of 21 that are going to multiply to give me a positive 21, but add to give me a negative 10. So I come out with x equals 7 and x equals 3. No, that's a long process, guys. So what do we need to do now? We need to go back and we need to check with 7 and 3. So let's try 7 first. So I'm going to say 7 times 2, or 2 times 7, minus 5, minus square root of 7 minus 3. Does that equal 1? Well, 14 minus 5 is 9, so square root of 9 minus 7 minus 3, square root of 4. Does it equal 1? 3 minus 2 equals 1? Yep. So I know that x equals 7 is a valid answer. So now let's try 3. The square root of 2 times 3 minus 5 minus the square root of 3 minus 3. Does it equal 1? Well, 6 minus 5 is square root of 1 minus the square root of 0 equals 1. Does 1 equal 1? Yes, it does. So we just proved there that x equals 3 is a valid solution. Whew, 2 more. You guys are doing great. Same kind of concept, right? I see now that I have 2 radicals. One's on one side, one's on the other. So we're good. We can just go ahead and do what? Perfect. We can just go ahead and square both sides. So when we square both sides, what's going to happen here is that's going to cross out. So I'm just left with x minus 1 on this side. And then over here, we're going to have to FOIL. So guys, remember what this looks like. Square root of x plus 5 minus 2 times the square root of x plus 5 minus 2. When we FOIL this, here and here, you're going to be left with just x plus 5. Now when I go here and here, I have negative 2x plus 5, negative 2 root x plus 5, and negative 2, so it gives me negative 4 times the square root of x plus 5. And then negative 2 and negative 2 gives me a positive 4. Equals x minus 1. So let's clean up. I have a positive 5 and a positive 4. So I have x plus 9 minus 4 square root of x plus 5 equals x minus 1. So let's go ahead and get rid of this x and the 9. Let's move it to the other side. And I am left with negative 4 square root of x plus 5 equals negative 10. Okay, so far so good. So we're going to we want to isolate this radical, get it all by itself. So let's divide both sides by negative 4. So I have the square root of x plus 5 equals negative, we can divide top and bottom here by 2, so 5 over 2. So now we're going to go ahead, our radicals isolated. Last step, what we need to do to finish solving this is we're going to square both sides. So this becomes, my radical goes away, so x plus 5 equals, when I square top and square bottom here, this becomes 25 over 4. My last step is going to be to subtract 5 from both sides. So x equals, if I'm going to change this to fourths, I'd multiply the bottom by 4, so then multiply the top by 4, so it gives me 20. So I have 25 minus 20 gives me 5 over 4 is my x value. And then what do I need to do? I need to go back up and check just to make sure it works. So I have the square root of 5 over 4 plus 5 over 1 minus 2. Does that equal the square root of 5 over 4 minus 1? Let's get a common denominator here. Change this to 4s, multiply the top by 4. This is going to give me 25 over 4 minus 2. And then I'm going to change this to 4 over 4, so this gives me the square root of 1/4. Well, if I take the square root of 25, I get 5. The square root of 4, I get 2. And when I subtract 2 over 1, let's change to a common denominator. This will be 2, and this will be 4. I get 5 minus 4 is 1, and my denominator stays as 2. So I come over here and I say, okay, I got to simplify this. What is the square root of 1? 1 was the square root of 4, 2. Does 1/2 equal 1/2? Yes. Is that a fun, easy way to check? No. But do you need to do it? Yes. All right, let's go with one more, and then we're done for today. I know this has been a lot. We'll finish it up tomorrow. I look at what I have going on here. I have 2 radicals. I have one of them is attached to a plus sign, so I need one on either side. They're already in the right spot. Perfect. Let's just go. Square both sides, guys. Square, square. So I'm left with 4x plus 1 equals, when I FOIL this, root x minus 1 times root x minus 1. It's just going to cancel. Gives me x minus 1. Let me write it up so you guys can see it. It's square root of x minus 1 plus 2 times the square root of x minus 1 plus 2. So we go here and here. That's where the roots cancel out. And I have just x minus 1. So then I go here And I go here, I have 2 and 2, so that's going to give me plus 4 of my x minus 1s, and then 2 times 2 is 4. So we want to isolate our radical. You see a radical here, you want to isolate it, get it by itself. So let's combine and move stuff to the other side. So x negative 1 and 4 is plus 3 plus 4 times square root of x minus 1. So we're going to subtract x, subtract 3, subtract x, subtract 3. 4x minus x is 3x. 1 and negative 3 is minus 2 equals 4 times the square root of x minus 1. Isolate this radical, so we're going to divide both sides by 4. So we have 3x minus 2 over 4 equals the square root of x minus 1. How do I get the square to go away? We're going to square both sides. So remember, top and bottom. So this becomes 3x minus 2 times 3x minus 2 all over 4 squared is 16 equals x minus 1 over 1. FOIL, 3x times 3x is 9x squared. 3x and negative 2 is negative 6x, negative 2 and 3. So this is going to give me negative 12x. And then I have negative 2, and negative 2 gives me plus 4 over 16 equals x minus 1 over 1. Now I have a fraction equal to a fraction, so we can cross multiply. 16 times x minus 1 equals 9x squared minus 12x plus 4. Distribute, so 16x minus 16 equals 9x squared minus 12x plus 4. I have a quadratic, so go ahead and move everything to one side, set equal to 0. So minus 16x and plus 16, minus 16x and plus 16. I have 9x squared. Negative 12 and negative 16 is going to give me a negative 28x, and then 16 and 4 is going to give me plus 20 equals 0. Can we factor this? Well, 9 times 20 is 180. Are there factors of 180 that'll multiply to give me 180, but add to give me a negative 28? Absolutely. It's going to be negative 18 and negative 10. Negative 10 and negative 18 is a positive 180. Negative 18 and a negative 10 when I add is a negative 28. Remember, guys, your a term is not 1, so you're going to divide both by your a term. So you're left with x minus 2 and 9x minus 10 equals 0. Solve. I have x equals 2, and I have x equals 10 ninths. Now, is 10 ninths fun? No. Can you go back and check it? Yes. Do you need to? Yes. So look at, oh my gosh, this problem is long. So I'm going to plug in 2 first. I'm going to come up here and plug in 2. So I have the square root of 4 times 2 plus 1 equals the square root of 2 minus 1 plus 2. 4 times 2 is 8 plus 1, so I have the square root of 9 equals 2 minus 1 is square root of 1 plus 2. Well, square root of 9 is 3. Square root of 1 is 1 plus 2 is 3. 2, all the way down here, is a valid answer. Now, folks, 10 ninths. So I have the square root of 4 over 1 times 10 over 9 plus 1. So I'm going to make it 9 over 9 because I know that's what my denominator is going to be. And then I have square root of equals the square root of 10 over 9 minus 1 is 1 over 9 plus the whole number 2. So let's work this out. I have 40 over 9 plus 9 over 9. Let's keep simplifying here. This gives me the square root of 49 over 9, which becomes, well, the square root of 49 is 7, and the square root of 9 is 3. So let's work over here now. So 10 minus 1, this gives me the square root of 9. Guys, this should actually be, oh, I wasn't thinking, hold on. This should be 9 over 9. Not 1 over 9. So if I have 10 ninths minus 9 ninths, this gives me square root of 1 ninth plus 2. All right, well, let's simplify. 2 over 1. So I have 1 third plus if I change this to thirds, I multiply the bottom by 3, then I multiply the top by 3. It gives me 6. So 6 thirds equals 7 thirds. Does 7 thirds equal 7 thirds? Oh, yes, it does. So 10 over 9 is a valid solution. The next examples, guys, what do we have? 1, 2, 3, 4, 5. We have 6 more. I will do those tomorrow.